All right, here we go. Um, this is the last question on our notes for 5.5, and it's a good one because you'll see on this question here the y-axis, which is when usually when t is equal to zero, is not going to be a critical value. Everything that we've seen so far, we've been able to have a critical value at zero. Like the guy on the Ferris wheel, we started the stopwatch when he was at a low point. On the spring case, we were able to start the stopwatch when it was either high or low. Okay, but the real world doesn't always work out so nicely when we're observing it. Not that we're doing an experiment, but we're observing nature. We can't tell the tides, hey, tides, you wait to come in at a high tide until midnight. No, the tide's going to come in and go out regardless of what time it is, and we have to observe it. Now, I was at the coast this weekend. It was really nice. I got to watch the sunrise yesterday from the back porch of where we were staying. It was really cool. But we walk on the beach, and we could see the stuff that was washed up overnight because the tides roll in and the tides roll out, right? Now, the highest tide differential in the world, that is in the universe that we know of, in the galaxy, in the whole wide, on Earth at least, the highest tide differential on planet Earth happens in Nova Scotia in that little inlet right there that's called the Bay of Fundy. Approximately every 6 hours and 14 minutes, the high tide and low tide switch. Okay, so the tide rolls in and the tide rolls out every 6 hours roughly. That's pretty quick, right? Now the tide difference is almost 56 feet. Can you believe that? So it's 56 feet lower 6 hours later, and then it's 56 feet higher. That's you got to be if you're like camping on the beach at Padre Island or Port Aransas on Mustang Island, and you're in a tent or you park your vehicle near the water. You got to be mindful of the tide rolling in at night because it can sink, it could wash you out to sea, or at the very least sink your wheels into the sand. But if you're in the Bay of Fundy and you park there, what's going to happen? You're going to be submerged, right? You're going to be underwater with 56 feet of water. It's pretty incredible. Okay. Now, what if we assume that on a particular day, we're out there walking around and we observe the low tide at 8:45 a.m. Not at midnight, but at 8:45 a.m. We want to figure out what it is. Now, to give you an idea of what the tides are doing, I found this little 30-second video on the YouTube. Let's just look at it and see how good it is. It looks like it already played. Let's play it again. Bless you. Okay, so you see the boats are submerged, and then here comes the tide. It's literally lifting the boats up. Oh, it's time lapse, so it probably sailed away. I doubt it sunk, right? And then here's the tide going out. And so those boats are actually sitting in mud. See that? It's dry. It's totally dry, and they're sitting in mud. And then the tide comes in and raises the boats again. So that's pretty incredible, right? I'm not just blowing smoke up your leg here, right? It's a real event. Well, then they should park it somewhere else, Brady, right? I guess, right? I mean, what would be your solution? You're a thinker. I need to use my boat, and I know the tide is going to roll out. Should I park it somewhere else? Your hose, all right, so you can like fill the water up in front of you and give yourself a channel that you could. Yeah, I like that. Yeah, just always travel with a water hose that's connected to tu- oh, that'd be a long hose. I thought you would carry the water on your ship like a big old pool. Like, yeah, just install a pool on your ship, and you could drain water right out of the pool to the bay in front of you, and then you can use it. That's a great idea. That's clever problem solving. That's going to suit you well on Wednesday on the SAT, I guarantee it. Okay, now let's go ahead and see if we can gather our information here, because what we want to do is come up with a graph, and we want to eventually write an equation. We're after the equation, but we get the graph first. Okay, so let's think about it. 55.8 feet. Let's go ahead and use the calculator because we're going to be dealing with decimals. We might as well pull the calculator up right away. No sense in trying to add or subtract decimals in our head. We're not showing off to anybody, are we? Minnesota. Man, if Minnesota ever secedes from the Union, we're going to be in a heap of trouble, aren't we? This wouldn't be free anymore. Oh, yeah, people just cram it in there. They don't really care. And that's the only rule in class I have is to care. All right, so we can figure out the difference between the high and low, can't we? If you want to sketch like a little graph down here, here's t equals 0. We want to measure what's happening since midnight. So if we read carefully, it says, sketch the graph of the tides in feet. So we're measuring it in feet for the entire 24-hour day. Assume the sinusoidal axis is at y equals 0. Okay, so that's pretty cool. So y equals 0 feet is going to essentially be sea level. And the graph is going to go above and below the sea level. So that's good. All right, so do we know the high point? The high point was 55.8, or is that the total difference? The total difference. So we could say sea level would be right in the middle of there, can't we? Yeah, so let's go to the calculator and let's do 55.8 divided by 2. That's 27.9. What number should that represent? The amplitude. Good. 27.9. So this is my rough draft axis, by the way. I'm going to make a prettier one here in a little bit. So this is 27.9, and this is negative 27.9. Okay, looking good. Looking good. All right, so now I've got my A. What should my D value be? It's 0 in this case. Yeah, that's nice. That's nice. All right, so the range, we get the range. The range is going to be negative 27.9. That'll be below sea level. And then it rises to 27.9 above sea level. Sea level is equilibrium. Now remember, the C is what we wait on until we get the graph. That could be anything. And so it's back to what the person that came in for help this morning says, this is the part I always struggle with. Well, that's because it's the part that requires the most thinking, okay? Finding the period and the B and getting the graph set up on the x-axis. Which of those is easier to get from the graph or the information? The period, right? And now notice that we're measuring time in minutes on this axis. So this is going to be time in minutes. And then we have feet on the y-axis. All right, so let's come down here. I know that at what was the time we saw low? What did it say? 8:45. So I'm just going to come down here and say low is at 8:45. Low is at 8:45. Now I know from low it's going to come up to the axis point, and then we're going to observe a high tide 6 hours and 14 minutes later. So I need to do a couple things here first. 6 hours and 14 minutes. I need to convert everything to minutes. Everything to minutes. Okay, so how am I going to do 45 minutes? Or how am I going to do 8 hours and 45 minutes? I need to convert everything to minutes, including the 8 hours. It's going to be larger numbers, but it's okay. 8 hours is how many minutes? 8 times 60, right? Yeah, so 480 plus the 45, this comes out to be 525 minutes. So notice I put the 8:45 above it, but that's really 525 minutes after midnight. Would you agree? Okay, now I need to convert. This is my, first of all, 6 hours and 14 minutes from a low to a high. Is that the full period? What fraction of the period is that? That's half. So I know that half of the period is 6 hours and 14 minutes. So I know that half of the period is, let's convert it to minutes. It's 6 times 60 plus 14, which gives us 374 minutes. Now from there, I need to go two things. I need to know the quarter cycle, because that's my counting interval, but I also need the period. Let's go with the quarter cycle first. How do I get the quarter cycle if I know the half cycle? Divide by 2. So let's divide that by 2, and I get 187 minutes, which is a little over 3 hours. Okay. That's your quarter cycle counting interval. That's the most important number on here. All right. In fact, I'm going to store that as X. I'm going to store that as X, 187. Okay. Because it's going to be that important. Now I need the period because I need to find the B. So the period is going to be 4 times that, or 4x. That's 748 minutes. So every 748 minutes, we're back to a low tide or back to a high tide, or sea level going up, going down. Okay, let's go ahead and finish filling this in over here. The period is 748. And then what would the B become for our equation? 2 pi over 748. Yep. 2 pi over 748, which we can simplify to, what's half of 748? 374. So pi over 374. Okay, now we have enough information almost to write the equation. We just need to know where we are on the x-axis because we need those marks so that we can say, positive sign, positive cosine, negative cosine. All right, so let's go back to our sacrificial axis here. I know it's at a low point at 8:45, so I'm just going to come out here and I'm going to say at 8:45, which is 525 minutes, it's at a low point. What you want to do is work backwards. If you know where you are in relation to the y-axis, to the left and to the right, you'll have all you need. Okay, so how do I work backwards from 525? What's my quarter cycle counting interval? 187. So again, this is our sacrificial axis. So I'm going to do 525 minus 187, which I stored as x. That gives me 338. I'm just going to put a mark here and call it 338. So there's another critical value to the left of 525, yes? Is there another one? Well, let's subtract 187 from that, and I get 151. So there's another one right here, 151. Let's go back again, minus x, and I get what? Negative 36. So I'm just going to come over here and put negative 36. I'm not really worried about the spacing just yet. I'm just worried about, how many critical values am I going to have between where I observed and midnight? So it turns out there were 2 other critical values to the left of 8:45 a.m. And now that I know what the negative value is, it's negative 36, and then the positive value, 151, I can figure out what my spacing is going to be. This is going to be small, right? This distance here is going to be a small distance. And then this distance here in purple, this is going to be roughly what? About 5 times bigger? Because about 5 times 36 is 150. It needs to be bigger, right? And then, of course, once I have those 2 values, then the distance between those 2 is going to be my quarter cycle counting distance that I try to preserve. So my question to you is midnight, which is t equals 0, going to be a critical value? No, it's not. Okay. So now I can go to my final graph. Okay. So I'm going to come over here. Let's go ahead and give ourselves a nice y-axis. And I'm going to draw my x-axis right in the middle. Maybe scoot this over a little bit. Okay, that gives me something to work with. Okay, so let's go ahead and put our final y values now. 27.9, we'll call that right here. And negative 27.9, about the same distance. Let's go ahead and call that feet. That's feet above sea level. And then I'll come way over here and I'm going to say time in minutes since midnight. All right, putting down the first mark. I'm going to go to the left and I'm going to use blue for water. How about that? Negative 36. I'm going to put negative 36 right here. Negative 36. Now, the next critical value to the right was 151. I'm going to put that about right here. And again, that's what I'm going to be looking for. I'm going to be looking for the distance between critical values. Are they roughly the same on your graph? And is the relative distance to the y-axis in each of those the same or to scale? Okay, now I have that distance between critical values. I might need to extend my x-axis here a little bit to get a couple more points in there. Okay, so here we go. I'm going to put a mark here, and a mark here, and a mark here, and I got room for one more right there. 1, 2, 3, 4, 5. Remember, we need 5 critical values for one cycle. I have 6, so I'm going to see a little bit more than one cycle, which is great. Okay, so now let's go ahead and mark those up. I'm going to take my 151. My calculator froze. Let's restart it. I'm going to take my 151, and to that, to get the label for the next critical value, I'm going to add what? 187, which I stored as x. So that's 338. And then I can say plus x again. Take the answer. That's 525. And now if I've done it twice on the calculator, remember you could just hit enter, and the calculator knows what you're doing once you do it twice. So there's 712. Hit enter again. You get 899. So on and so forth, right? We could keep going now if we want. Same spacing, plus 187. Same spacing, plus 187. All right, now I need to go ahead and we didn't move the y-axis here, but I need to set the table set. I need to put my food on the table. What food goes where? Well, I know one point. It told me that at 525 minutes after midnight, which was 8:45, it was at a low point. So at 5:25, I'm at a low point. Is that enough to set all of the other critical values into motion? Yeah. Let's go back to the left. So 338 is going to be an axis point. 151 is going to be a high point. Negative 36 is back on an axis. And if I go to the right, 712 is back on an axis, and 899 is back to a high tide. And there you go. The hardest part of this problem is done. The hardest part was figuring out the period and the B value and then scaling it correctly on my rough draft x-axis so that my final graph was scaled correctly and only had the values that I needed labeled. Okay, now I get to connect. This is the fun part. I get to eat the food. Yummy, yummy food. We connect it with exaggerated quarter cycle arcs. We turn the corner to show that it keeps going. And our negative value is relevant here. Like when we did the Ferris wheel, the negative values for T they weren't relevant, were they? Because we hadn't started the stopwatch yet. The ride hadn't begun. When we did the spring problem, negative values of T were not relevant because we started the experiment at 0. But our negative value is relevant here. Yeah, the tide was going in and out before we got there and observed it, right? So if you wanted to predict where the tide was before you observed it, you could actually plug in the negative value of T and figure out what it was that you missed. But we can also predict going forward. So in this case, T is all real numbers, okay? It's not just greater than 0. T is all real numbers. Negative values make sense. All right, so I got my x-axis or t-axis labeled with minutes, and I got my y-axis height. Let's go ahead and put height. We'll put h there as the height above sea level. Okay, now that we have that, let's write an equation. This is A. So now we're on part B. I'm going to say h of t is equal to, and the amplitude was 27.9. Leave a little space if you want. We can't do it without a phase shift, can we? 0 is not a critical value, so we're going to have a phase shift. So does it really matter if you pick a positive or negative sign or a positive or negative cosine? Does it really matter? Absolutely not. It doesn't. So just pick your favorite one. Pick your favorite critical value. What do you want to pick? Sine? So what are you going to do for sine? Which value are you going to shift over to? You can shift over to negative 36, or you can shift over to 712, right? Now, here's what I would recommend. They told us about 525, yes? And I know that's a low point. The others I figured out on my own. Now, if you're confident with your work, you can pick any value. But if you want to be kind of sure, I would choose 525. So if 525 is a low point, which trig function is that going to be? Plus or minus sine or plus or minus cosine? Negative cosine. So I'm going to come over here and I'm going to put a negative 27.9 cosine of parentheses, and then the B value, pi 374. Another parentheses, and now we do t minus 525, close, close. And is it plus anything? No, it's plus nothing. Now, if you want to do what Brady was saying, no problem. Shift over to 36 and do a positive sign. 27.9 sine pi 374ths. And now it's going to be t plus or minus 36. Which one? Plus, yeah. If we graph both of those, one in y1, one in y2, we should see the same graph, right? Let's actually try it. What mode should we be in? Degree or radian? Radian mode. Double check. Your calculator should be in radian mode. Go to your mode and check. 1, 2, 3, 4 down. We're in radian. Looks good. Now go to y equals. Let's type in the first one. Negative 27.9 cosine of, it has parentheses, so alpha x pi. Use the pi button over 374. Click to the right. Another parentheses. We use x on the calculator. Minus 525. Close, close. Let's go ahead and type the other one in y2. Positive 27.9 sine of parentheses alpha x pi divided by 374, and then we do parentheses x plus 36, close, close. Now don't just hit graph, go to your window and go ahead and type it in the same window that you've created already. So I'm going to go from negative 36 for my min, I'm going to go to 899 for my max, and I'm just going to turn my scale off. I turn my scale to 0. We don't really need, it's not going to put marks at a regular interval because it bases it off in 0. So just turn it off. And then let's go negative 50 to 50. That gives us some room above and below 27.9. And then I'll turn my y scale to 0. That doesn't matter. Now we should see two graphs. They should trace over each other and they should both resemble what we have. Let's see. There's the first, there's the second. How are we doing? Are we awesome? We are awesome. Yeah. Now, if you want to do this, let's go back to the window. Go back to your X max. What if I was interested in seeing an entire 24-hour cycle in minutes? How about 24 times what? 60. Can we do the math right there in the X max? Can I type in 24 times 60? Or do I need to do that separately and then type it in? No, I can do it right there, and it changes it to 1440. Let's hit graph now. So there is what we exhibit on a day. So during any given day, you're going to see two high tides and two low tides. That's what makes the Bay of Fundy such a spectator event. You can literally go there, and you don't need a time lapse if you sit there long enough, like when I was doing yesterday morning with my coffee, watching the sunrise over Corpus Christi Bay. You can actually see the water level rise. You can see the water level going down. It's fast enough that you can observe it. That's pretty incredible. All right. We're done with the hard part. This is what your quiz is going to be tomorrow, but I probably will give you an easier one tomorrow where your phase shift is 0. Okay, but on our test, this makes a great free response question where the phase shift is something other than 0. All right, let's answer the question then. Part C. We're on part C now. At midnight, the morning of, what was the water level in the Bay of Fundy? And at this time, was the tide coming in or going out? Well, that's going to be the what? What are we going to plug in for T at midnight? 0. That's the y-intercept, isn't it? So let's do h of 0. Now, this is the easy variety. You could do it from the home screen, but since 0 is in our window, can't we do it straight from the graph screen? Hit trace, and don't scroll over there because it might not scroll to 0. See how it gives you ugly decimals? When you hit trace, just type in a 0. And since I went to negative 36, it'll give it to me. So there it is. The 3 decimals, it's 8.308. And then I'm going to put feet above sea level. I'm going to put 8 above sea level. And what? Rising? Yeah. And rising. So does that mean the tide's coming in or tide's going out? Yeah, the tide is coming in. That answers the question specifically, right? It didn't ask if it was rising or falling. It asked if the tide was rolling in or rolling out. When the water level rises, the tide's coming in. When it's falling, it goes out. Okay. Now, again, we could have done that from the home screen, right? We could have said alpha trace number 1 or number 2 of 0 and gotten the number, whoa, syntax. Oh, I did. Okay, thank you. Alpha trace number 1 of 0. I didn't look. I get that. And then if I wanted to know if it was going up or down, I could do alpha trace number 1 of, and then 0.1. I can go maybe a tenth or even a hundredth, and I can see that the value is a little bit bigger. So we could do it from the graphing screen as well. All right, so what's the other way that I could ask you? Well, instead of giving you an input, I can give you an output. Let's see what part D says. At 7:30 that evening, what was the water level? Oh, so this is another one like example A, where I'm giving you the time. Do I just type in 7:30? No, I have to come off to the side here and say 7:30 p.m. corresponds with how many hours after midnight? I mean, how many minutes after midnight? Is it times 7? No, we have to go military time. Times 7 times 60 will be 7 a.m. 19, right? If you look at this in military time, this is 1930. It's 19 hours after midnight. So I got to go 19 times 60. That's 12 plus 7, and then plus the 30. So that's 1170 minutes. So I'm going to show down here on my input H of 1170. Now I'm going to do it from the home screen. I know we have it graphed. I'm just going to hit second trace, alpha trace, sorry, number 1 of 1170. And it's negative 18.092, and that's feet. Okay, now that means that it's what? Above or below sea level? Okay, I'm not going to put negative 18 feet below, because if you say negative 18 below, that's a double negative. So I'm just going to put in parentheses here, below sea level. That's interpreting it. You got to be careful not to say that it's below by a negative number, because that means it's actually above. Okay, and then I'll just do alpha trace of 11. Oops, I need the parentheses. 1170.1, and I can see that it's what? It's going down. It's a smaller number, and I'm going to say and falling. And again, in parentheses, I'll interpret that the tide is doing what? Coming in or going out? Going out. Yeah. And then the last part here, let's see what it's asking us. Part E. At what time during the day was the water level 25 feet above normal with the tide going out? 25 feet above normal with the tide going out. Okay, so I can say H of T now either equals 25, or remember I told you could say H of T is greater than 25. Either one of those will get the check. I don't care which one. And now we go to Y2 or Y3. I'll go to Y4, so it's a different color than black. And I'll just type in 25. And if I hadn't done so already, this is where you're going to want to graph it over a full day's period. So now you would hit 24 times 60 so that you can see the full day, hit graph, and now we know how to do this type of problem. Now, it doesn't say for how many minutes was it above 25 feet, did it? It didn't ask for how many minutes. So we don't have to find the point of intersections and subtract. We just need to find the times of day. So those are just the points of intersection. But we want the tide going out. So we want it what? To be rising or falling? Falling. So there's two places on here where I see it's 25 going down. We'll find both of them. Bless you. Second trace number 5. Bless you. Enter, enter. Bless you. And there's the first one right there. So enter. So I'm going to say that that's going to be T equals 221.181. I'm going to store that. That's minutes. I'm going to store that as alpha A. So I go to the home screen, second mode quit, and I hit X, stow alpha A. All right, now I'm going to do the second one. I'll call that T sub 1. T sub 2, second trace number 5, enter, enter. We scroll over to the second one. We get close to it, we hit enter. And it should be a full cycle away, right? 6 hours and 14 minutes. So that's 970.363 minutes, and I'm going to store that one as B. Okay, so I hit X, so alpha B, 6 hours and 14 minutes later. All right, now, if I am interested, it says at what times. We can convert those back to 12-hour clock time, can't we? Which is what I would expect you to do on the quiz. So that's why I saved them. Let's come back to part A and convert it to clock time. So T sub 1 is going to be, how do I convert 221.81 minutes back to clock time? Do what with 60? Divided by 60. Yeah, we can speak up. That's what we do. So that's going to be 3 hours after midnight. So I'm going to say 3 a.m. And now I need, it's like when we converted from decimal degrees to degrees, minutes, seconds, right? Now I need to subtract the 3 hours and just convert the decimal part to minutes by multiplying it by what? 60. That's going to be 3:41 in the morning. And I can even go past that, can't I? I can subtract the 41 and multiply that by 60 and even get seconds. I'm going to do 10.909 seconds. So if you want, you can say that's AM. And the way that we read that when we have the double colon, if you're familiar with that format, it's hours, minutes, seconds, right? So 3:41 a.m. in the morning, about 11 seconds into that minute. 3:41 a.m., 10.909 seconds in. That's cool. You can observe when it's 25 above falling. And now you can either do one of two things to get the second one. You can either add 6 hours and 14 minutes to this one, which is not too bad to do. Let's try that. What would 6 hours and 14 minutes later be? 6 hours later would be 9 a.m. Oh no, I'm sorry. The period, not 6. I've been saying 6 hours and 14 minutes. That's half the period. We never figured out the full minutes. It would be 12 hours and 28 minutes, right? 12 hours and 28 minutes. Let's just convert it, okay? Since we found it, so we'll do the same thing, which would be a good review of what we did on the first one. So I take the 970. I kept saying the period was 6:14. That was half the cycle. See, I even forget. 9 concussions. No seizures, though. I get to drive again on April 4th, everybody. That's a little over a week away. That's going to be 90 days. I'm so happy. Divided by 363. My wife, oh, by 60. See, I don't even know what I'm doing. I was trying to convince my wife all weekend to let me drive. I was like, are you tired? Do you want me to drive? I was hoping she would say, sure. But she was like, no, it's not April 4th yet. And I'm like, dang it, you remember that I had a seizure. All right, so that's 16 hours after midnight. What time is 16 hours after midnight? It's 4 p.m., isn't it? 4 p.m., so I'm just going to put 4. And then I subtract the 16, and I multiply by 60, and I get 10. Oh, so 4:10 on the nose, right? p.m. Yeah, 4:10. And that's how you do a problem where 0 is not the critical value. How does that sound? You like those? They're fun. You're making sense of the real world. The real world. Okay, so your homework's due tomorrow. We're going to quiz tomorrow. It'll be one problem. It'll be a calculator problem, but it'll be more like the Ferris wheel problem, okay, where 0 is a nice critical value, and you can go from there. This type, because I want you to be able to practice this type a little bit longer, this type will be like your free response on the test. What was your question? You might need the linear velocity. Remember, if you're looking for the period is the reciprocal of the angular velocity. The period is 1 over the angular velocity, which is RPMs, okay? Now, you may need to convert the units, like from minutes to seconds, but if I tell you it's rotating at 6 revolutions per minute, you know the period is 1/6 minutes per revolution, okay? You flip it. But then you might need to do some conversions on the units, but you flip it. All right? Any other questions about the quiz tomorrow? Might I use one of your names in the quiz? I might. I might say Jasmine is riding a Ferris wheel in New York. Or maybe I'll send you to Paris. Would that be great? Yeah. Okay. Any other comments or questions? Homework will be due tomorrow at 9 a.m. Yeah. Finish it early so you have more time to study for the SAT.